In this tutorial, we're gonna learn what is the difference between entwine, graft, and flatten. So I'm going to use series. What series do is start from 1 point, such as 0, and steps of 1, and for example 100 times I would like it to be repeated. What series do is like sequence in mathematics, which creates a list of numbers which starts from that in this algorithm starts from 0 and repeated 100 times, which means the end will be 99. We can use these numbers or in many components, many algorithms such as radius, creating points or whatever. It's not important the usage of these numbers, but if we use Param Viewer, we'll see that we have data with one branch, which means that all of these series are only in one branch, which has 100 items. Now if I right click in this component, the output of a component, and select graft, we'll see that we have 100 branches and in each branch only one item. So what graph do is data inside the algorithm will be separated in different branches. So what graph exactly do is that it uses the smallest items and convert it to not convert it, but put it into a different branch. When if I choose flatten, we'll see that it is opposite of graft, which as it was remain, and there's only data with one branches, which means that it is one branch with 100 items in it. I'm going to create a list of numbers. Right clicking on it and select multi-line data. And for example, again right click, edit its multi-line data, and I use entwine. What entwine do is flatten and combine a collection of data streams, which means that it will connect all of the lists, all of the branches that we have now, one list, two lists, or two branches, and then it will be put it in one data stream with two branches. In this way, we're going to create more efficient algorithms and prevent copy and paste multiple times in just one algorithm. So the result will be more efficient algorithm. Now, if I right click and choose flatten, it means that I don't want the data stream, and I want just one branch with all the items in only one branch. So what it means is that before it was two branches, but after that, when I right click and select flatten, we destroyed this stream data and we converted it to just one data stream with one branch. So before it was flattened, we had the first list was in one branch, the first, and which had 5 items in it, and the second list with 6 items in it has the second actually branch. So you can see that Entwine and this flatten graph and stream data is for managing the data in algorithms in order to make more efficient algorithms. For now, I'm going to make 3 circles and then move these 3 and then move this 3. What I'm going to do is I would like to loft each 3 of these circles. So if I am an amateur grasshopper designer, I will use curve and select multiple curves and loft. But initially I'm going to move this. And then for example I will copy and paste and separately select these curves. And the result will be like this, But someone, for example, will come with another solution and say, what if we choose all the lines together? As you can see, this is the result. So it cannot address our problem. Then what I'm going to do is I use Entwine. And then connect each of these and use one loft to see what will be the results. So this is the result when I use Entwine. You can see that what Entwine do is maintain this separate curves, maintain the branches, and as one data stream, our lofts are created. Now, for example, I would like to know if I can use I can select all the curves together and see what will the result and what components I should use. As you can remember, there was a component which could specify the center of the areas, in this case these circles. Then we had a component which with that we could understood about the sequence of these items that we draw in Rhino, which was point list. Now you can see that the sequence of these curves of these circles are a bit messy. So I used partition list in order to convert it to as a size of partitions. I would like to partition each 3 items into sublists. Then I will use bang or explode tree. Bang or explode tree are the same. What bang do or explode tree do is exactly opposite of entwine, which means that it will get one data and then it will separate it into the branches from a tree. So we can see that this branch, which is 0, 0, is 0, 1, 2. Then the next branch is 3, 4, 5, and the next will be 6, 7, 8. So if I, for example, hide this, not this, and hide this, and connect it to a curve, you will see that our first branch is 0, 1, 2, the next is 3, 4, 5, and the next is 6, 5, 8. Now I would like to look to the sequence of these numbers. 0, 1, 2, the next is 3, 4, 5. I would like to reverse the sequence of this branch because I want it to be the same as the previous branch, which was started from here and ends from here. So what I am going to do is right click on the output and select reverse. And again, for the next branch also, I would like to start 6 here and end 8 here. So again, right click and select reverse. So now if I use entwine again, and select these branches, The result will be there will no difference about the data streams and branches. Again, we have three branches with three items in it. But if I connect the result to this, you'll see that now we have three branches which start from 0 and with 2. So what is the difference is that when we use partition list, we restarted these sequences. Previously, we could see the sequence based on the curves that we drew on Rhino. But now what we have is that after using this partition list and then reversing the numbers, the sequences, the result will be having three branches starting which each branch has three items in it, started with 0 and end with 2. So for example, if I select flatten in it before I mean if I don't want to see what happened with this partition list and entwine, we can see the result of this explode tree is that it's 0, 1, 2, 3, 4, 5, and 6, 7, 8. This flatten actually the data which comes as a result of entwine will be flattened, but without this you can see what happened here. If you back to the loft, actually we made this example to see how we can loft without separating these curves manually and separating them actually parametrically. If I, for example, use loft, the result will be that like this, because the loft has connected the items in one branch, which it's not our desirable result, because we want to put these three and these three and these three, connect these three items, not these three circles. So in order to loft these three circles, what I should do is fill up this parameter, which means that I want these zeros to be to go in only one branch, and these ones go to one branch, and these twos go to one branch. So, which means that now what I have now is like this. But what I want is I want these three on one branch, and then this three, and then this three. In order to reach these branches, I should use flip matrix. So if I type flip matrix, the result will be this. Initially, maybe these components, all of these components and these rules seems so difficult, but when we continue it, when we repeat it in our future algorithms, we will definitely understand when and how and where to use each of these components.